Hi, this is Thomas Stepan, and today I want to talk about how to demonstrate digital up conversion with the M8190. Before I go into the live demonstration, here's a quick overview and a block diagram of how digital up conversion works. In traditional, what we call direct mode, DAC samples are stored in our memory, and through an FPGA they're sent pretty much directly to the DAC. In digital up conversion mode, on the other hand, we're storing IQ samples in memory, and we're running them into an Agilent proprietary ASIC where we do interpolation and a complex multiplication with the output of a numerically controlled oscillator. This oscillator has a number of really nice benefits. It has high frequency resolution and phase resolution. It can perform sweeps, and it can do amplitude scaling, and all of that can be controlled in real time under sequence control. So with that, let's go into our live demonstration. I'm going to use IQ tools to control the M8190, and let's bring up the instrument control dialog. The first thing I have to do is select one of the digital up conversion modes. So unlike the direct modes up here, I'm going to pick one of the digital up conversion modes. For the demo, I'm going to pick X12, and I set the carrier frequency for this example to a gigahertz. At first, I will use the multitone utility and generate some simple modulated signal. Notice up here the sample rate, by the way, is shown as 600 megahertz. This is the baseband sample rate, so we're generating a baseband signal now. And I will use a simple multitone signal, say minus 20 megahertz and plus 50 megahertz. And I download that. And let's look at this on the spectrum analyzer and see what happens. So we got our two tones. Let's reduce the bandwidth a little bit. So our carrier frequency, you can see the center of the spectrum analyzer is set to 1 gigahertz. Our center is right here in the middle. And this is the negative 20 megahertz, and this is the plus 50 megahertz signal. Now you notice, unlike conventional up conversion, where you would normally see a little bit of LO feed-through signal, or a little bit of an image. If you do in the negative 20, you would also expect to see a little bit of a positive 20. With digital up conversion, you don't see any of that. And the best of all, you can go in here and open up the digital up conversion demo utility. And with that, you can change the frequency and the amplitude on the fly. And I'm going to show you that right now. So simply move the slider here, and you can change the frequency and you can change the amplitude on the fly without reloading data. You can also do this whole thing under sequence control, and there's a couple of nice demo buttons up here. Just click on the moving multitone, for example, and it will show you a 5-tone signal that is changing in amplitude and frequency on the fly. You notice how fast this was downloaded? This is because it's the same IQ baseband waveform used for all of these signals, except that we're changing the frequency and amplitude of the NCO. You can also do the same thing with a pulsed signal. This is a chirp where the frequency changes and the amplitude also changes. And also this one is a nice demo because it puts the spectrum analyzer in zero span mode, as you can see down here, and it records the data over a period of about 8 seconds in this case, and you can see the amplitude is changing in the course of 4 seconds here. This is a high frequency pulse signal. By changing the span back to 200 megahertz, you can actually see it is a pulse signal. The other nice thing you can do with digital up conversion is affect the phase of the signal programmatically. For this purpose, there's another example down here, the coherent pulses demo. And I just push the button for coherent pulses, and I look at the oscilloscope and see what we get. So on the oscilloscope, we can see the waveforms of channel 1 and channel 2 of the ARP, and you can see both of them are generating a pulsed signal. And the signal on channel 2, the green one, has a steady phase, whereas the channel 1 signal, the phase is moving back and forth under sequence control. Very powerful for phased antenna applications. This concludes the digital up conversion demo, and I have a separate video for showing you how to use the sequencer to program these things individually.